Okay, thanks. Andreas, thank you a lot for your kind introduction. And of course, for the invitation to the seminar. I'm very happy to, I wanted to say I'm very happy to be here, but that doesn't make a lot of sense in that online setting. So I'm very happy to speak to you about a topic that is very important to me, and also I think is at the same time a bit hyped and also underappreciated. Like, it's a paradoxical situation, but we may talk about this later in the discussion. I will talk about embedding the past. Andreas has already said it. We have a project that is also named by that. So that's kind of the marketing thing that we need to put out. And I will be talking concretely about from visual artifact to semantic data, AI-supported workflows in digital scholarly editing, maybe AI-supported workflows in digital history. I think that editing is also changing with the impact of AI, but we can also talk about that later. Now, yes, now that works. Okay, so usually when I present or talk about the topic of AI, I always start with this slide or kind of an updated version of it. I think this is from yesterday, which is a diagram of the development of NVIDIA shares. I could also have taken, I don't know, Google shares, any other big tech company shares, just to remind us, which I think is very important, that what we are talking about is not only a technology, but it's also a huge, huge business, at least since the year 2022, when ChatGPT was first published. And you can see that until then, the development in terms of financial development is really incredible. So we are talking about a big business in which mostly big tech companies, but actually also a lot of other companies are trying to attract, but also to justify really massive amounts of investment into that technology, into data, but also in the computing power. NVIDIA is a company that produces the hardware that is needed for that development. I think that's something that's very important to keep in mind, because in order to justify and to attract this investment, I think the big tech companies have very successfully put something that I want to call a very strong, sometimes utopian, but sometimes dystopian narrative out there. We can talk about the idea of the singularity. I think that was very prominent 2 or 3 years ago, the idea that very soon the AI and machines will become so powerful from a cognitive point of view that they will surpass human ability, and then there's no way to control them, and we don't know what's going to happen. That's a very, very strong narrative. But there are also other narratives. I'm sure you have read about this project, how it's called, Glass, I think, like the new anthropic model that is said to be a huge threat to national cybersecurity because it's so powerful. I'm not saying that's not the case, but it's really important to understand that many of the things that we read in public discourse is really put out there deliberately in a way to make this technology either attractive or to make people think that if we miss that, we will end up on the losing side. So we really need to invest into that technology. And it's actually often very difficult to separate what is true from those marketing and hype mechanism that we are faced with. There's also currently, I think, a bit of a more realistic narrative that is put out there. I'm myself not quite sure what to make of it, which is that very soon there will be a widespread replacement of human knowledge work by AI. We are mostly talking about that in terms of programming. Is it still worth learning programming? A lot of programmers will lose their jobs, which I think is also true at the moment, that there is a big shift in the job market. But who knows if this is really only AI or if there are also other economic patterns in place. Now, mostly we are talking about programmers that will be on the losing side. However, a recent study done by Microsoft, and again, we need to think about this business context, but a recent study done by Microsoft also is talking about how historians in our workflows can be replaced by AI with AI coverage of our presumed workflow, like what they think we are doing, of 91%, only surpassed by interpreters and translators with 98%. Now, I think there is a lot we can discuss about that paper. I think some parts are actually worth remembering. Other parts are clearly a misstatement of what we do. But the takeaway that I have, every time I show this slide to historians, I typically get 2 types of responses. The first is either a triumphant dismissal of this replacement future where we are replaced by AI, mostly based on anecdotal failure of an AI system on a specific problem, maybe on your research question where you say, look, this letter from the 16th century, the AI has transcribed totally wrong, and this will never, they will never replace humans because they are not capable of dealing with this complex historical data. That's the one response. And the other response on the other side of the spectrum, and I'm a bit, say, Holzschnittartig, it's a bit simplified, but that's basically the spectrum. Some colleagues react with either a negative resignation or a positive anticipation of the automation of their score skill by AI. So very typically, when people try to do complex translations, let's say of a difficult Latin source, and then the AI gets better and better by iteration. Currently, they are quite good in translating also complex systems. Or if they feed a handwritten document into an AI system and it gets transcribed correctly, then people are saying, oh no, nobody will need us. Or they say, great, this is something I don't have to do in the future. Now, both responses, I believe, belong to what I want to call a discourse of substitution, which first frames AI primarily through the lens of its potential to replace us as historians, or at least some of our core tasks. So we look at it and say, can it replace that? And then we are either afraid or we think it's great because we don't have to do it ourselves. And secondly, what it kind of does, it's conceptualizes AI almost as an entity that is capable of doing something, and then it's an antagonist to what we do. So we say, okay, this is AI, this is an entity, and it can either replace us or it cannot, but it's this kind of discourse of substitution. Now, I think that's a very bad framing of the potential and issue of AI, and maybe we can discuss this later. It might actually be kind of a self-fulfilling prophecy if we tend to look at AI in this way. And what I would propose is to really understand AI on the one hand only as a tool set. AI systems are just tools that enable us to do something, or maybe they don't enable us to do something. And second, I really want to think as AI as kind of I call that epistemic infrastructure, which is basically not an entity, but it's an infrastructure on which we can perform our communication with historical sources and history. And that's what I'm going to talk about today. Now we have finished the introduction. I first want to talk about AI as, I call it, just a tool. So this is just a tool set we can use, in this case for digital editing. And then after that, I want to think about the potential of AI to change the way we engage with history on an epistemological level and think about it as a machine to think with. And then we have a small conclusion and hopefully a discussion in the end. So let's start with just a tool, AI as a tool for digital source editing. Now, I think we can all agree, and we probably have all used this in the past, that since the 1990s, around the 1990s, we have actually witnessed an enormous wave of digitization driven mostly by GLAM institutions, galleries, libraries, archives, and museums. In our case, probably mostly archives and libraries that are digitizing historical sources, which actually means creating a representation of the visual artifact of the historical source. So here you can see a typical digitization workflow where you basically have a camera that makes pictures of a historical source and then stores these pictures in a digital format, so we can use those pictures on the screen from our desk. We don't have to go to the library and read the actual book, but we can browse through the images of that book. And that's actually very comfortable, and it's a great thing. I think that our way to deal with historical sources has changed dramatically since the 1990s, since we don't have to go to the library, at least not every time. And it's also very comfortable. You can even sit on your couch with your iPad and browse through historical sources. However, taking pictures of books and documents is not enough for proper digital research with these texts, because what we end up with is basically only a representation of the visual aspect of the text. We make a picture of a text, but we don't create really a digital representation of the text itself or of other phenomenon on that page that we might be interested in. So what you can do with digitization, with these images, you can read them on the screen, but you read them the same way that you would read the actual book in a library, sequentially and basically you in an analog way, whereas you cannot, for instance, use Control F and search the image itself for a term that you are interested in, and you cannot perform any kind of digital analysis on the actual text. In order to do that, what we need to do is we need to transform the digital image of a text into a textual representation, into a structured representation of the content of the text itself. And that I call, I'm not sure if it's a canonical distinction, but I make the distinction between digitization, which is creating a digital image of a document, and then datafication, datafying this image into a structured maybe even annotated and semantic representation of the text. Now, the problem with that is, I don't really know, but I think we are probably in the range of billions of images that have been created from all kinds of historical data. Like we have a huge mass of images. When it comes to the datafication of these images, we are really, really lagging behind. Like most of the corpora that we are talking about, handwritten corpora, historic corpora, are not datafied in a sense that we can really work with them on a digital level. And the reason for that is that it's actually very, very costly and takes a lot of effort to create this datafication. Making the pictures quick, putting it into a datafied representation, that takes a lot of time and money. Now, I've brought you an example just for you to have a concrete example of what I mean with that. And that's, Andreas has mentioned it, is taken from the digital editing edition from the Decretum Boccari. I'm going to say about that something later. And basically, when we are talking about digital editing, what we mean is datafying the actual source. So we have a research question, and then we datafy the image or the document in a way that we can answer our question with that. And usually we do that by creating a TI representation, just like people in the Salamanca project are doing with prints. We are doing it with handwritten document. What is the Decretum Boccari? Just very quickly, it's basically a canon law collection of the 11th century. So we are talking about church law. It's very big, was compiled by Burkhard of Worms. And it's interesting for us because the manuscripts we are dealing with have multiple traces of editorial revision. So it's a very complex edition project. But basically what we try to achieve is we want to put this image, this is an example image of the manuscripts we are talking about, into a machine readable form. Now, in the case of the Decretum Boccari, that has an enormous scope. We are talking about 1,800 chapters. Other collections of that period even have more chapters. So those canon law collections are really, really large documents, really large text corpora. And for our editors, we are talking about roughly 150,000 lines that they need to transcribe and then also to annotate. Transcribing is not enough. We also have to annotate them. And now you can imagine that this kind of datafication, that takes a lot of time and a lot of effort. Now, if we have a look what that actually means, datafication and also digital editing, we end up with kind of a layered workflow that we have to go through in order to turn a historical document into a sufficient textual machine readable representation. In our case, it includes layout recognition. Then we need to transcribe. Because we are making a digital edition, we preserve the abbreviations and then we have to expand them afterwards. We have to apply normalization, punctuation, and then, of course, all kinds of content annotation. And as I said, that takes a long time and is very cost incentive. Now, up 10 years ago, if we would have said that maybe we can use a machine to automate some of these processes, that would have been deemed impossible until the invention of a technology that we call deep learning. I'm sure everyone is familiar with that technology, which is basically based on the idea that we don't program computers explicitly do that, but we just give it input data and the expected output data, and then the computer should learn the pattern itself and can then apply it to unseen data. And we can actually apply this to mostly all of the steps in that workflow quite successfully. And what we do at Darmstadt at the moment is we try for each of those steps and many more, we try to develop, train models, provide data sets and implementations that are based on deep learning and what we call the Digital Editing Toolkit. So there are very different models we use for different steps of this workflow. Now I'm just skipping through because then I want to actually show you how it works. For instance, what we have is we have a layout recognition model that can not only identify text, but it can also annotate these regions based on their function in this layout system. We have text recognition, several text recognition models. Here it creates what I call graphematic transcription. We have a model that is capable of expanding the abbreviations. It's a text-to-text model, some for normalization, punctuation, and so on. But now I try to show you in practice. So I hope this works. No, works almost. Sorry. Can you see that notebook? Just need to see if I'm in the right notebook. Okay, great. So basically, when we want to datafy the Decretum Boccadi, we basically have two choices that we can use. We can either use the editio princeps from the 16th century, which we could, for example, use if we just want to have an analytic entry point to the data. And I brought you this example because it's, I guess, quite similar to prints that other people are working on. This is very typical layout and typeface for the 16th century. Later, I'm going to show you the workflow for the handwritten manuscripts from the 11th century, but just that you see that it's possible for printed material as well. So what we have here is basically a workflow that is based on the idea that we take an image provided by the library, and then we perform certain editorial steps by using AI models. In this case, what has already been performed is firstly the layout recognition by a model. And here you can see the visualization of that outcome. So we have these text regions that have been identified, and also this is color-coded, the function of these layout elements in this layout system. And the data, I think we've used Kraken for this. This is how the data looks like. Here you see, you don't have to read that, but just you see all these kind of coordinates that are basically the coordinates that make up these lines and the text regions. And you also see the annotation. In this case, this region was annotated as type of a header, and then we can visualize that here. Now for the prints, we have a bit of a problem. This layout recognition in general works pretty well, but it only detects the layout elements, but the actual segmentation is not limited to the text regions, but also inherent to the text regions itself. So for instance, here you can see that a new chapter is introduced by this kind of title and this initial, and this is something that cannot be detected by detecting the region, but we need to make an analysis of the individual lines in order to capture the segmentation of the chapters. Now we do that by applying, here's another side. And what we do is we use a system that basically performs a geometrical analysis of these individual lines that has been provided by the layout recognition model. And then we can use it to classify each line, in this case, as a line which is probably a title line. And then we also use the same mechanism to determine as a fail-safe. This is probably the first line of a chapter because it has an initial, and that means it usually is smaller than the other lines, because this is important for later. Initials are very difficult for recognition models to handle. And what we can then do is we can basically classify each line and segment it into the belonging chapter. So this is the structuring of the textual data that I was talking about. Then there's another issue. Here you can see this is a chapter, but it started in the page before. So because we are segmenting page by page, this is a bit of a problem, but it's also something that we can deal with by using geometrical analysis. And here you can see what we do. The system can successfully identify this part of chapter 2, which started the page before, as this is a chapter that started the page before. Here we have the next chapters, 3, 4, 5, and it also was able to map these elements on the margins to the corresponding chapter. So in the end, what we want to have an output where each chapter has its title, the chapter, but also the belonging. This is kind of a footnote where the text comes from. It needs to be mapped to the actual text. Here we do it just yet. You can see that it also works for other pages as well. This is a book out of the Decretum Burkhardi, a large chapter and color coded. You don't have to see everything in detail, but you can just see that it's able to segment this data into a structured format. Here we have taken out a snippet, one chapter. I think it's chapter 14, just to show you something else. Here you can see this has been successfully segmented. And now we go to the textual part of the problem. This has also been provided. I think this comes from Transkribus. Yeah, it comes from Transkribus. Here you see Transkribus, the model has produced this transcription. But one issue is that we only, most of the time, do not have any visual hyphens. Okay, here you can see up, center, basically one word has been split by a line break, and only in one case we actually have a visual hyphen. So that's the problem. If we just take the data as it is and we try to reproduce a floating text, up and center or far and for will not be put together as one word, but as separate words. And that will be a problem for future processing of the data. So what we did is basically on the Salamanca data, which is very, very useful data, we trained a model that is capable of taking those words at the end and beginning of the line and then classify if those are likely to be separated words. And then as you can see here, I hope you can see that it actually predicts correctly. In this case, up, center is classified as, we use this TI system. Here is no word break, ventilator and sententiam. Here's a word break, and so on. So it helps us, the model helps us to reconstruct the actual text that was present but not properly encoded in this typeface. And then later what we can do, we can export this. And here you can see, for instance, here is chapter 2. We have extracted the rubric, which is the title, Ut comites et judices politicio munera. Here didn't work, but it's probably my error with the implementation of this notebook. And then, yeah, here it works. We have the body text that has been reconstructed from this page. And then in the end, we have this, it's called inscription, this footnote. And what we have done here for these, I don't know, 10 pages can now be done for, I don't know, 100 pages, 1,000 pages, whatever you want. And it takes not a lot of time. Just a second. Now, very quickly, we also see, I probably have to change again. Very sorry for that. And I need to find the right notebook. Yeah, here we are. Andreas, you tell me you can see that.
Yeah.
Yes. Okay. Now, when we try to do that for the manuscripts, it gets a bit more complex, but in essence, it's the same. Here you can see again, this layout recognition is coming from Kraken, I think, and also the transcription is coming from Kraken. So AI tasks that were performed before that in a similar step. And as you can see, more or less the layout is pretty similar, with one really important difference. The individual chapters are not segmented by titles that are kind of narrower than the rest of the type, but it's color coded. So the rubric is red and also the initials are red. And that's a big problem for layout recognition because it can really not handle well these color differences. So what it usually does, it will not recognize the initial. And also it's not possible, or really only very badly, to teach the model that this yellow line is basically a new chapter. So we are missing this information that here a new chapter begins, so we cannot segment it. So we need to do it in another way. And also it means, because of the initials are not identified as as initials, they can also not be recognized as text. So we end up with a transcription that is missing always the first character of this chapter. Here you can see that, I hope. Here, cum extra clericorum ordinem. This is here, and it's missing the N. And the issue is with some of these elements, that's very easy. Emiliter, you can map this to similiter. There's no, like, it's very easy to map this. The problem with if there's written, that could be anything. Like if the word before would be, I don't know, justitii, that would not be an initial. There are a lot of words that can end with an in the next page. So we really need to find a way to identify, okay, in this case, it's probably a missing initial. And we also did that, again, as with the line detection, by training a model that uses language, a statistic representation of language to understand, okay, in this case, this or this tem or this emiliter and this epe is not just a broken word, but it's probably a word where the first character is missing. And it can do that by understanding how these paragraphs are usually built. And here you can, I'll come back to that later. Here you can see this is the output of the model, which has learned that in this case, tem ubendum est probably is missing an e, item, similiter, nam. So that works pretty well by using this model. Otherwise, it would be really difficult to establish the missing character. And I think it's only possible to do it by hand, but by using AI, we can basically restore that. Now, what we did here, we used computer vision to identify the red lines, and then we used that to segment this page into the individual characters. Then again, the initial restoration. Then we used another text-to-text model to perform the expansion of abbreviation. I'm not that happy with that. It could be better. Andreas and I, we were working on a new iteration, so I think this will become better. But mostly it works. Ex concilio, that was expanded by the system. Yeah, in this case, capitulum. Those are easy abbreviations, but it's in general it's capable of expanding this abbreviation system. Here, presbyterum. That's a mistake that I'm not sure why it makes this mistake, but I think we can make this better in the next iteration. So we can use this to perform the expansion. Then again, because in the manuscript tradition, we also don't have any hyphens, so we need to rely on that line break recognition I've already shown you. You can see villicati oni in the next line here is written together. Then we have a normalization model, which is also a text-to-text model that performs normalization. For instance, villicationi gets normalized to with v. That's how we want it. Presbyterum, here's still the error from the expansion system, but we want it with this epsilon and so on. So this can produce the normalization for us. Then we create the text flow. It's something it's hard to see, but here just the text is getting reconstructed together. And then we have a model that has been trained on text without interpunctuation, and then we have mapped it to text with interpunctuation. So the system learned how to perform basic interpunctuation. Not perfect, but in general, here for instance, item ubendum est, comma, ut nemo, and so on. It's not perfect if you're a philologist or an editor, but it really is a massive help if you are an editor who needs to apply the interpunctuation because you have something already in place, which more or less works pretty well. And it's also very important because many automatic analysis tasks actually need to chunk the text into meaningful segments. And for that, we need a modern interpunctuation, even if it's not perfect, just to give the machine to understand the relevant segments of the text. And then basically we do the same. Here again, we map the marginal items to the corresponding chapters, and we can export that into a structured way where we have here, for instance, chapter 4, the title, De Principius Reasonable. Then we have the inscription, and then we have the textual body, which is not perfect, but we can then give it to an editor who corrects it manually, or if we just use it for, I don't know, topic recognition or something like that, we can even used it. And that's basically the way where we can use AI to go from just a visual representation of a document in an image to a structured and then annotated format that we can then later use. So let's go back to the actually works, the switching to the presentation. Now the question is, I mean, I've shown you the prints, and I mean, if you don't have an editorial approach, but just want to work with large source corpora, you can really do mass datafication of these sources very quickly if you can accept, let's say, a couple of percentage of error rate because you're not interested in philological detail. And that brings us to the point where we will, I think, very soon end up with very, very large corpora of historical data, and where we need help by a machine to deal with this abundance of data. And here AI comes into place as an epistemic infrastructure. I'm skipping a bit through the slides because I think I'm running out of time. I just want to show you very quickly how deeply the idea of the scarcity of sources is enshrined into historic methodology. And that will become a problem, I think, in the future. We can use Marc Bloch, for instance, who has written the Apologie der Geschichtswissenschaft, which is a famous introduction into the work of the historian, who said that actually the gathering of documents that a historian deems necessary for his question, that's the most difficult task that a historian faces. And that was true for a long time, because you had to go to an archive, you had to have finding aids. Like, it wasn't easy to know that in this cloister or abbey there is a manuscript that might be interesting for your question or a document. So that actually for a long time was the fundamental constraint of historical methodology, the scarcity of sources. We also have Carlo Ginzburg, who basically said the same a couple of years later, who was talking about the scarcity of testimonies, and who said that, I really like that image. Basically, historians are something like hunters, and humans have been hunters for millions of years. And we learn to really send out, to observe the details, to interpret the most delicate traces, web find signs, even in historical data, because we don't have a lot of that. So if you want to answer questions about the past, we really need to hunt for the traces. Now, the problem is with this AI facilitated datafication of our sources, I said we have billions of images, we want to datafy them, but that means we will end up with billions of data, with a large amount of data, which is basically like the haystack that we are talking about. And then I think this notion of the difficult task of gathering documents is actually flipped on its do you say from toe to head? Because it's not difficult to find it because we don't have any data, but we have so much data that how can you select what it's worth for your question? And that's something which is also true for the Decretum Burcardi, 1,800 chapters. How can I find in those 1,800 chapters what's interesting to me if I cannot read the book from beginning to the end? Maybe I also want to compare it to other collections where we have, I don't know, 2,000 chapters. That's not possible. Now here also AI comes into place, mostly in the form of embedding models. I'm not sure if you're familiar with that. Probably you can ask in the discussion later if I'm too quick. Embedding models basically are high dimensional representation of language, and they know the semantic relation between terminology and words. So if I use an embedding model and I query for marriage, the system knows that maybe the term adultery or celibacy or divorce or something, they have a relation to that word. So it might be able to give me back textual chunks, even if the terminology I was looking for is not present, like just based on a semantic relation. And that's very useful for an AI architecture we call RAG, Retrieval Augmented Generation, which is basically an architecture that allows me to have a query as a human. I can ask a question, send it to an LLM, large language model, and then the LLM does not answer that question based on its own knowledge, but it uses such an embedding model to query, let's say, a database or a text corpora and see if it finds relevant sections of the text in relation to the query, then sends this back to the LLM, and then the LLM can use this information that has been retrieved to formulate a transparent and hopefully right answer. And this is something that we in Darmstadt are trying to fine-tune this model to make them work with historical sources. And then there's also another aspect of this. This is pretty technical. It's called MCP, Model Context Protocol, which is basically a technical way to enable the communication between the large language model and the knowledge base, the corpus, the database that we wanted to use in a way that we provide. So this is a technical way to tell a large language model, for instance, hey, here's the corpus of the Decretum Burcardi. I have this function written for you. Please do your lookup this in this way and give it back to me in a certain way. So this is basically an interface between the large language model and the knowledge base. And then what we can do with that, this is an open source solution. That's why it's a bit ugly, because I have designed it myself. Is we can generate this kind of retrieval system where we can ask, in this case, I think it's Llama model. It's a bit of a stupid question. What does the Decretum Burcardi say about unfaithfulness in marriage? And then the embedding model retrieves these documents. And then the large language model doesn't hallucinate something, but can base its answer on the retrieved documents and even gives me back this idea. And what's really cool, I just did that in the last couple of months, we can also use this MCP server to give, for instance, a proprietary large language model. In this case, I used Claude Desktop because I think many people are using that. We can use it to give it access to our database. So here, I hope you can see that. This is just to show you that here under connectors, my MCP server actually opened a couple of methods to the large language models. And here you can see Burkhardt BGE, that's basically my MCP server. Here we have a couple of things that it can look for parallel chapters that are similar to a chapter that I input in Burkhardt. It can, but it can also look for things. And now I show you how that works. I have prepared a video, but I hope maybe later we can also use the system live. Sometimes it doesn't work. This is the question. I'm a researcher interested in human-animal relation in the Middle Ages. I use this to show you that like cultural history is always a bit fuzzy, right? I mean, I often don't know what I'm looking for. I'm trying to explore human-animal relation. How would I find that? How would I start this exploration in the source corpus? So I think this is a difficult one to tackle. And then I tell the system, does Burkhardt's decree contain any notion about this topic? It knows from the MCP server that it has access to this corpus. And then also because Claude can do that, I say, please structure your response using HTML widgets. Don't have to do it, just I think it can do it. Now let's see what happens. Now we send it to Claude. Then here you can see loading tools was very quick. It recognized there is a tool it can use. It has access to a database that I provided. Then it performs this method search Burkhardt. I have access to the MCP server. Let me run. Then he performs a query based on human-animal relation. This takes a bit because it works on my machine. So that works locally. It retrieves the information based on this RAG pipeline that we created using the embedding models that are on my machine. And then basically it's trying to find a way to visualize this in a good way. Takes a bit. It would have taken a long time if I would have done this manually. And then what it does, based on the data that I provided, this is not just knowledge that the LLM thinks it has, it really worked with my data. It basically gave me back all the relevant answers to my question, categorized it, and that's important, gave me back the actual ID, or in this case, formatted as a string that I book 2, chapter 214, and it gives me back a citation of the actual text that it found in the database. And it's very interesting. I think it found quite interesting references to animals and the relation. And then it goes on, preparing me this data. And building an overview, I mean, I don't know if we as historians need that overview, but I think it's always, yeah, a nice thing. And that answer is much better and actually grounded in the actual material compared to an answer to the model when it does not have access to my data. So that's basically the important takeaway. So 5 minutes, wrapping up, going back to the sorry, that wasn't necessary. Can you still see it? No.
Not yet.
Yeah, sorry. I thought I'm outside the presentation. Okay.
Yeah, it's back.
Okay. Okay. So basically, now that looks pretty seamless, I think, because we also made use of this cloud functionality. It actually is a lot of work because we have to prepare the models. Most retrieval models are not made for historical data. They can deal with Latin, but we need to fine tune. Then we need to create the technical foundation, the implementation, the MCP server needs to be programmed. We need to prepare the data set. So that's a lot of work. And we are doing that in the context of this Embedding the Past model project, which is a Löwe exploration dedicated to giving AI responsible access to our sources. I just reference it here that if you're interested, we are always open to collaborate on new data. So just get in touch. Just to give you an idea of what's necessary to actually implement what then in the end looks pretty easy. And then Andreas already mentioned it. What's really important is, I mean, this is the technical implementation, but I really think we really need to reflect the epistemic implications of this systems, because I think they will change fundamentally how we engage with history, either because we do it, we provide, we do the implementation and the reflection, or some company will just do something that they think historians want to do. That's mostly a bad outcome. And that brings me to the conclusion very quickly. Now, I hope I have shown the potential of AI for datafying the source material, but also then how it helps us to really deal with this new abundance that we have. And I think I also mentioned the epistemic implication. There are two very, very big epistemologic implications that we hopefully can discuss later. The one is that this kind of systems, they help us to dissolve this tension between, in literature history, we call close reading and distant reading, right? Up until now, you could either make close reading, you take the text and you read it carefully and then base your argument on it, or you can do a datafying of a corpus and then make a distant reading where you have a look at 1,000 texts, but you don't really have a way of seamlessly zooming into the individual. So there was no way to move between those two types of engagement. And now I think with these models, embedding models, but also the large language models, what we really can do is we can dissolve this tension into a scalable reading. Basically what I just did, we could say, okay, in this large corpus, I'm interested in this, find all the chapters that deal with that, but then in the later stages of the dialogue, what I could say is, oh, chapter 5 is interesting. Can we zoom into that? And then it can open the chapter or it can perform its own analysis of that. So that's really a big thing in digital and the methodology of digital hermeneutics. And the second thing, very, very quickly, is something I'm also only thinking about. I don't have a final view on that. But when I'm working with Burkhardt, I'm always reminded of Reinberger's idea of epistemic things, where he says that in the natural sciences, let's say we are talking about radiation or something, if we want to study that, we cannot study radiation. We can only study, for instance, radiation if we have a certain apparatus in place that kind of makes it tangible for us. For like there is a reading that makes that if the radiation gets stronger, and then we see there is something radiation, and then if we manipulate the radiation, maybe the feedback gets quicker or smaller. So that helps us to grasp the phenomenon. And basically, I think we also need that for digital history, because if the haystack becomes bigger and bigger, and our questions might be at the beginning maybe vague, animal-human relation. We don't really have a epistemic thing that we can grasp, right? What is animal-human relation, and how can we explore that? And here, I think those embedding models and large language models really help us to explore large corporas in a way that helps us to form an object that we can then later research. And the last slide, very interesting because this is from 2010. Basically, all my ideas about this epistemology has already been formulated by Willard McCarthy 10 years or 20, almost 20 years before we were actually capable of doing that with large language models, where he said in another context, where this desire takes us is ultimately to our own ignorance of how we might render our core activity interpretation into a digital medium. That really was a big issue. And what we now do with computing, and have done quite well in many cases, is to serve the interpretive act by delivering nuanced information, it is by embedding interpretations in metadata or data structures, which is fine, though inadequate, as I noted earlier. What we have not done and don't know how to do is to build a computational equivalent of a musical instrument. It is an instrument which allows the interpreter's mind to engage at a point and logical way of inquiring using large language models into our data basically allows us to engage exactly in the point of interpretation using this technology. And I'm very excited applications of that with you a bit more, but also answer all your questions. Okay, that was my input. Thank you very much for listening.